Hey everybody, let me just get some sound checks going on here. Okie doke. Looks like my signal's a little poor. Just give me 1 second. How is the audio? Sounds good. Okie doke. Okay, guys. So we're gonna go ahead and try to figure out how to turn off this banner. There we go. Okay, cool. So today we're going to do is we're going to look at importing some infrastructure into existing infrastructure into some Terraform or OpenTofu templates. So we're going to show a couple of things. We're going to take a existing RDS database and we're going to bring it into the official Terraform AWS module, the RDS Aurora module. And in doing this, we're going to use OpenTofu, so we can show how OpenTofu's interoperability with the Terraform registry modules. And then we're going to use that state, push it into Massdriver's Terraform state server, and show how you can actually fully import infrastructure into Massdriver using Terraform state management tools. So we're going to get started there in just a minute. I'm going to go ahead and set up just a couple of screen share things real quick, and we're just going to be pretty much live coding today. So we'll see how this goes. And I got comments open. So I'll be responding to comments periodically. Any questions, just feel free to drop them into the comments, and some of my teammates will either answer them or I'll answer them depending on who sees them. Okie doke. So let's go ahead and start by sharing a screen. So what we're going to do today is we're going to take, let me find my, there we go. We're going to take this Terraform registry module for RDS Aurora, and this is what we're going to import. And so what we're going to see is it's a pretty impressive module. It's got a fair number of resources inside of it. You can see it manages about 16 different AWS resources. Now, we might not bring all of these resources into this module, and that's fine. But this just gives you an idea of like the scope of this module. And it is a pretty big module. And this is one of the things I think is pretty interesting about the public registry is, you know, some of the modules, you come in here, you'll see that they've got a really good collection of the cloud resources that you can kind of put together to make a really good module for managing this infrastructure. But on the other side, like, while it does give you this great roster of like the resources to be looking for, right? I'm not just deploying an RDS cluster. I'm deploying the policies with it, subnets, CloudWatch logging groups, like all these things you do want to have kind of in the same life cycle. The problem with this is a lot of times you'll see that there's just a ton of variables that go into it. And this can be pretty overwhelming for developers on your team that don't necessarily know Terraform. And so, you know, when we think about what we do as operations, DevOps, platform engineers, SREs, et cetera, whatever your team calls it, what you really want to do is try to enable that developer self-service, like give them good DevX around whatever your platform is, whether you built something internally like Massdriver or whether you're just using GitHub Actions as like the platform you're delivering to your developers. You want to be able to give them modules that they can understand. And this is important for a couple of reasons. One, as an ops person, like you don't necessarily want to give away all of your guardrails and policies and conventions when you enable developers to manage your own infrastructure, right? You want developers to be able to make a database, but do you want them to think through your high availability concerns and like zonal replication of Postgres? Maybe not, right? Maybe it's a production system and it should always be in 3 zones, right? And so what we're going to do today is we're going to take this module that has this really big scope. We're going to bring in some existing infrastructure, and then I'm going to show you how I think about the inputs to these modules and how I can design them for the developer that I know is going to be using them, make it very easy for them to kind of come in and interact with Terraform without necessarily being a Terraform guru or an AWS guru or an RDS guru, but they can get the Postgres instance that they want. They can be able to configure things like the version of Postgres or maybe some of the database parameters, et cetera. So today we're going to see a lot of databasey Postgres stuff. This is just for illustration. This isn't a how to become a master at running RDS Postgres at scale. It's just kind of focusing on some of these conventions. So looks like we've got a couple of people here. So I'm going to go ahead and didn't realize I wasn't sharing my screen that whole time. So sorry about that. So this was the module I was talking about. Apologies about that. Sorry. So the resources that we're going to be creating are here. And then if you look at the inputs, as I was mentioning, like it's pretty intimidating. If you were thinking about standing up a Postgres instance and you hadn't used Terraform before, and your ops person sent this module over to you, there's like 127 inputs. You kind of have to like think your way through. So with that, I'm going to go ahead and screen share. We are going to bop back and forth between some code and a couple of web pages here. So I'm probably just going to do a full screen just so I don't end up in this scenario again where I forget to share my screen. So go ahead and take this off. And I'm going to do a full screen situation. Let's do this guy right here. Okie doke. So what we should have is a browser over here. We'll be coming back and look at some Massdriver things here in a little bit. But for the most part today, we're going to be just kind of staring at this code console. So let's max this one up a little bit. Can somebody from my team let me know if the font scale is good or the font size is good enough? If anybody has any issues seeing any of the code, please feel free to just say the font needs to be a little bigger. Or somebody already told me it needs to be a little bigger. Okay. Hello world. Y'all can see this? I'm going to assume so. I got it looks good. Okay. So what we're starting with is a pretty blank slate. I've got just a little examples folder here. This only has the variables of that module that we're looking at. Again, this is a pretty intense module that we're going to try to bring some existing infrastructure into. So this file is just the only thing here is just to kind of show what the interface to that module looks like and give me something I can reference. But we're going to start with some pretty bare bones code. So the first thing we're going to do is we're actually going to use Massdriver's Mass CLI to generate something that we call a bundle. And this is what we're going to be importing this infrastructure in. And so I'm just saying this as kind of a segue to the UI a little bit later. But after I run this command, pretty much everything that you see from here on out will just be typical Terraform or OpenTofu flow for doing importing and managing resources. Just one step that I'm going to walk through. But I want to kind of walk you through this and talk about some of the concepts that we have that make Massdriver a pretty interesting Terraform or infrastructure as code automation tool, as well as an internal developer platform. So I'm going to go ahead and do mass bundle new. And so what this does is this is going to hit your GitHub repo or whatever, and it's going to look at all your different templates for running infrastructure for your engineers. So in this case, we're going to see in a second is my team's put together maybe 20 different templates that you can kind of bundleize and ship. And what we're going to do is we're going to make one today called Terraform, AWS, Aurora, PostgreSQL. And so we're essentially going to publish our own module of Terraform or OpenTofu code or Helm or whatever into the Massdriver registry. And that's where we're going to be running this stuff from. So I'm following the typical Terraform naming conventions for this module. But the one thing I want to point out here is kind of my first take on like how to do really good DevX around designing Terraform and OpenTofu modules or even Pulumi components or CloudFormation components. So if we go back to this RDS module, the Aurora RDS module, you can see that there's a ton of different parameters here. There's a lot of different information that it's prompting you for. And if you hop over and look at the actual source code, what you'll see is under the hood, pretty much all these variables are just directly mapped back to an attribute. And I personally feel like this is kind of an anti-pattern, right? If you're sure you're backing up, a couple of different resources, right? It's good to know what resources should be together in a module, but you're not really adding a lot of expertise with this module, right? Literally everything is just passed through. So you're kind of getting this like very anemic abstraction, right? One of the things I get most out of these public registry modules is just the idea of what 16 resources to put together. And what I'll usually do is I'll just write all my Terraform from scratch because I like to own it. But today what we're going to do is we're going to focus on this module because I kind of want to show how to take one of these big modules and scope it down to something that's a bit more manageable. So why am I saying this? Well, the bundle that we're going to make is very specifically focused on AWS Aurora PostgreSQL. And this is important, right? When you look at a module like this, the AWS RDS cluster resource is a really powerful resource. If we look at the Terraform, what we'll see is this thing can manage MySQL instances, right? It can manage Postgres. It can manage, I think, a couple of other databases, MS SQL, possibly Oracle. There's a whole number of databases that RDS can manage. And this is one of the first things that you can do to kind of make your Terraform modules a bit more manageable is focus on a specific use case. Don't focus on a cloud service. When you focus on a cloud service, you have to account for literally every single one of these attributes here. And when you start grepping through the page, what you'll see is there'll be some parameters in here that are very specific to MySQL, right? And so if we design a Terraform module that focuses on the cloud service rather than a use case that we know exists in our business, what happens is we're putting additional burden on the user of this module to figure out what to do, right? So if there's settings in here around MySQL's logging specifically or bin log replication, right? A developer at my company that is using Postgres never needs to care about that stuff. And so one of the first things I like to do is kind of just filter that stuff out. Make a module that's focused on a very specific thing, giving somebody Postgres or giving somebody MySQL. And then that is a whole class of attributes that you can kind of just scratch off your list of things that you have to support. Gives you better forward compatibility, less chance of breaking changes. You're not trying to balance a bunch of configurations that you're not really even using in production. It's really funny. I feel like when you look at the development world, we've got all these great principles. We've got KISS and YAGNI, keep it simple, stupid, and you ain't going to need it. But a lot of times when we're designing Terraform modules, I feel like we're just kind of pushing everything under the sun into it, right? Am I going to need serverless to scaling? Well, not if your company doesn't use serverless configurations, right? If you're not running serverless databases, like that's something I don't need to ever expose to the developer. And if we've decided as operations engineers that we don't want to run serverless, why even expose it in the first place? And so that was a bit of a long tirade. So the point is this module that we're going to publish is specifically focused on PostgreSQL. So I'll go ahead and hit enter here to go ahead and start generating this. Manage AWS or PostgreSQL instances, just a nice description. This will show up in the UI later. And this is where the templates come in. So one of the really cool things with Massdriver is you can kind of design these pre-built, almost think of it as user interfaces and like CI/CD in one. And you can package up these different templates. You can push it into your Git repo, and then using the Mass Bundle New CLI, you can generate essentially bags of code that adhere to one of these templates. And so what we're going to see is I'm going to hop down here. My team has a Terraform module template. I'm going to select this. And what this is going to do is it's going to do a couple of things. It's going to essentially set up the Massdriver provisioner to run Terraform or OpenTofu when this is getting executed. And it's also going to create an alternative configuration file, a Massdriver YAML, that lets you put really rich validation and information in the Massdriver UI for your modules. So we'll actually see when we publish this in the Massdriver is the Terraform module itself changes the user interface of Massdriver. So you can really get a nice internal development platform, but instead of your operations team going and learning TypeScript or React or building web servers from scratch, the extension model is just writing Terraform. So it's a really great way to take an operations or DevOps team that has skills at writing Terraform, skills at managing infrastructure, but they want to kind of scale themselves, empower their developers. They can do that with Massdriver pretty easily without having to learn an entirely new stack. So I'm not going to import a module per se here, so I'm just going to go ahead and skip this. And then this last part is it's asking about connections. So one of the cool things that Massdriver does is it works across all infrastructure as code tools. And as a part of this, if you're familiar with Terraform or OpenTofu, there's this concept of a remote state where you can kind of pull remote state from other resources. In Massdriver, we have that same concept. We call them artifacts, and they work across IaC tools. So like a Helm chart can actually pull information from a Terraform module. or two different Terraform modules can pull information from each other. Or if you got some old stuff on CloudFormation and you're starting to move to OpenTofu, you can actually read information from your CloudFormation configuration into OpenTofu. So if you need the VPC ID that you built with CloudFormation, you can pull that into a Postgres module in OpenTofu. And so this is just asking about the different artifacts that you want to import. You can also customize your own artifacts in Massdriver, but we ship about 90 of them by default. And so what I'm going to do is say I need an IAM role. Whoops, I messed that up. Sorry about that. Hit the wrong key. Okay, let's get down here. This, skip that. I'll take a role. And then the other thing I know that this is going to need a VPC to connect to. So I'm going to go ahead and say I need a role and a VPC. And then it's going to prompt me for variable names for each of these. So I want to refer to my role as my AWS credentials. And then I'll refer to my VPC as just VPC. And I'm going to output that here. Yes. As you can see, I walked through this tutorial earlier. So now if I go ahead and list my directory here, what you'll see is a couple of things got created. First, there's this install script. You can use this to install all the GitHub actions, et cetera, into your Git repository. So this is automatically setting up your CI and managing it. There's an operator guide right here. When we get into Massdriver later, you'll see this operator guide shows up as a run book on the side. So you can essentially pack a bunch of operator information into this, how to troubleshoot Postgres, how to troubleshoot RDS, how to restore, a backup, etc. You can pack your runbooks right alongside your Terraform, and then when your developers are managing their infrastructure in our UI, they have the runbooks right there too. So really getting that developer self-service like maximized. We don't just want developers to deploy infrastructure; we want them to be able to troubleshoot it as well with your ops team's guidance. And then finally, we see the source directory here, and that's where my actual Terraform module is sitting. So an important note here for Massdriver users that may be watching that are following along for the first time, like kind of making their own bundle, importing infrastructure. One of the key concepts of Massdriver is not only can you use these artifacts to talk across different infrastructures code tools, but the Massdriver bundle is essentially a packaging mechanism for infrastructure CI/CD. So in this case, we're just running a single Terraform module. But I can actually take Terraform and Helm, or Terraform and Checkov and OPA, or Terraform and Checkov and Helm and OPA and Infracost, and I can put them in the same bundle and package them together. And what happens is instead of having a bunch of CI pipelines that your developers are constantly copying, you get this packaged functional piece of software that can provision infrastructure with all of your policies in place. So what's nice is once I publish this and you start seeing me diagram it later in the UI, as an ops person, I don't have to worry about, did my developers have the right version of Terraform? I can update that once in my Massdriver YAML file, roll it out, and everybody that uses this bundle will get the new version. If I start throwing in OPA policies or checkoff, I can just put it into this module. I can update my Massdriver YAML, publish it, and now whenever my developers run these modules, all of a sudden it starts running checkoff and OPA or Infracost. So it's a really good way to just completely lower the maintenance burden of infrastructure as code and CI/CD pipelines while giving your developers that feeling of control of the cloud. So, okay, that's all we got for that. I'm going to go ahead and start doing some codes. That was the Massdriver pitch, and I'll steer clear of it for the next 20 minutes. Okay, so we got that generated. What I want to go ahead and do is I'm going to close this guy here, and I'm going to go ahead and open my main TF. Let me just drop this. I didn't change anything there. And you can see as when you generate a new module with Massdriver, it just kind of throws in a basic resource here. So what I want to do is I want to go ahead and bring in that Terraform module that we were just looking at. And I'm going to go ahead and just hard code a couple of values here. So this is the Terraform AWS module, the official one. So we built our own module that is wrapping this module. And what we're going to do is we're going to use our module to lower the surface area of this RDS Aurora module to make it very Postgres specific. So you can see I'm calling my module here Postgres, referencing this. I'm just going to use latest for the latest version for this demo. You probably want to pin a specific version if you wanted to prod. And then I'm just going to kind of hard code a couple of values. What I like to do is I like to just see, I'm a test-driven engineer. I like to just see green as much as possible as I'm kind of going through my workflow. So I like to just get stuff going pretty quickly. And seeing some sort of success. So what I'm going to do is I'm going to go ahead and do tofu init just to get going. And you can see Tofu, OpenTofu initialized this empty directory. That's fantastic. What I want to do is also hop over here and look at my providers. So Massdriver auto-generated a provider config. I'm going to go ahead and actually just kind of uncomment or remove a lot of this stuff because I know exactly what config I want here. So I'm going to essentially enable the AWS provider. I'm going to set it to 5.62. We'll look at some of this other functionality here in just a minute, but just kind of trying to get a base level for this module setup. So I'll come over here and I'll do tofu init again. And this should start, oops, I'm not in the right directory. There we go. And this should start downloading all my modules and my providers so I can start running OpenTofu. Give that a minute. I'm going to check for questions really quick. Okay, nothing over there. Okie doke. So it just takes a minute for that to download him. So what you can see here is I did tofu init, and even though I was looking at something from the Terraform registry earlier, you can see that it's actually grabbing it from the OpenTofu registry, and now it's starting to install my plugins. So OpenTofu has a public registry, also open source the code for it, where we mirror all of the modules that are published to the Terraform registry as well as providers. Sorry, we don't mirror the registry. You have to open a PR to push the registry ones in there, in case any of the lawyers from HashiCorp are watching, taking notes frantically. Sorry. Okay, so that tofu init worked. I'm going to go ahead and just run a tofu plan, right? We don't have much over here, just a couple of hard-coded values. I'll do validate first just to make sure all the Terraform looks good. That should come back pretty quickly. Configuration looks valid. I'm going to do a tofu plan, and we should hopefully see that it expects to create a bunch of stuff. But as I said earlier, we have some actual infrastructure that we're going to kind of bring into this module. So cool, it looks good. So it's going to try to create an AWS security group, and it's also going to try to create my cluster. But this is something that I have already, and that's what we're going to bring into this module. And you can see a couple of the hard-coded values I have there. So I'm feeling pretty good about this right now. Let's put it in prod. Just kidding. So now when you're starting to import infrastructure into Terraform or OpenTofu, the hardest part isn't the Terraform commands. It's not learning HCL. One of the hardest parts about importing infrastructure is finding the infrastructure that you actually want to bring under control. If you're at a smaller company, this might sound silly. If you're at a larger organization, you probably already have like 4,000 or 5,000 different cloud resources, right? And so one of the hardest parts is like trying to figure out like what of those modules, right? Like this module, we saw all these different resources that are in here. How do I find these 16 resources in my AWS account? And how do I get the right ones, right? How do I know that this subnet is the subnet that this database is in, right? That's just hard to do if you haven't had good tagging and naming conventions. So luckily my team is pretty good about our tagging and naming conventions. So I get like a massive shortcut here. But if you were doing this and you didn't have really great tagging conventions, you'd probably find yourself in the AWS console kind of just hunting and pecking for resource IDs and then copying and pasting it into Excel or something like that. So I always advise people when you're starting to go on a big Terraform importing or OpenTofu importing project to first start with going in and getting a really good tagging convention around your resources. So I'm going to go ahead, and that's not what I meant to run. I meant to grab this little snippet. And this is just an AWS command that lists all my resources that have a particular tag ID. So I'll just kind of show you what I did here and what I'm looking for. So so again, if you're an Azure customer, GCP customer, they have similar tools for kind of querying resources based off of tags or labels. So what I'm doing here is I'm just trying to get all the resources, just the orange, just the identifiers that have this package ID set to this value. And so this is a database that I know exists in Massdriver. And so what I'm looking for here is I'm looking for the cluster identifier, which is right here. So this is what I'm going to use to import this real piece of infrastructure into this module. And so the way you do this, if you haven't done an import before, there's actually a couple interesting things with import. So I won't go into it. I'll just kind of mention it here. But what this import command is going to do is it's going to take the Terraform module that I have and the remote cloud information. It's going to hit AWS, look up this cluster information, and then it's going to pull that information into my Terraform state. And then when I run my Terraform plan, I should see how this very minimal config that I have so far would try to change that infrastructure. And we're probably going to see that it's going to do something bad to this database, but we're going to take it step by step and kind of refactor it and get it into a place where it works without destroying any infrastructure. Now, the other thing that you can actually do with this tofu import command and the Terraform import command is they do support code gen now. And we have a couple of different webinars and blog posts on using that functionality, and also using that functionality with ChatGPT 4.0. And you can get some pretty good code generated out of it. So if you just use the code gen, what happens is it just dumps the resources right into your code base. And then it's essentially each attribute, it just sets the value just directly. So you'll see like cluster name, you won't see any variables. So it doesn't generate the best code, but it does get you a really good baseline. But we're not going to do that today because we're going to try to bring it into this bigger module. So I'm going to run Terraform import and then kind of give it the module address of this resource here. So this is module.postgres. Now, when you're importing things into a nested module, you have to know where the address is of the resource you're trying to get into. And so I'll hop over here, kind of look in the code base for this module, and you can see there's this RDS cluster, that I need to target with where I'm going to put this database information. So I'll do this. Now, one thing that sucks, and I forget this all the time, and I literally lost 45 minutes of my time this morning running through the demo because I just forgot this. You have to account for resources that there may be multiple of, right? So I'm seeing this and I see, yes, it is RDS cluster this. And that's exactly what I'm looking for, is that resource address. But this next line is the tricky one. It's effectively an array of these because they're using this count attribute. And this is a bit silly in my opinion. Like, I love using a for each to create multiple resources when it makes sense, subnets, policies, something like that. But a very common thing that you'll see in these Terraform registry modules is you can essentially say whether or not you want to enable the management of a resource. Hey, I'm going to use the RDS Aurora module, but I don't want to make a cluster with it. I don't know when that makes sense, but apparently it does to some people. And so you kind of have to deal with this when using this module. So you're not dealing with an RDS cluster, you're dealing with an RDS array of a single cluster. It's kind of goofy, right? But you have to know that when you're addressing this. So we'll address it as the 0th index of this, and then we'll put in the just the cluster identifier, which is the last part of the ARN, 5xj1, I believe. Crossing fingers, looked like that happened. I'm going to go ahead and cat Terraform state JQ and just kind of pipe it through JQ to make sure it got this. Okay, there it goes. Sweet. So I was able to import that into my state. So now what I have is, I'm going to slide over here to the sidebar. You can see that I've got, again, this is my Terraform source code right here in this directory. I've got this Terraform state file that just came down through that state command. So now I can do a tofu plan over here. And you remember earlier it said that it was going to create two resources, the database and a security group. Now, since this is in my state, Terraform and OpenTofu should tell me that it's going to try to change something. And I'd say that it's probably going to delete this database if I apply it. But let's go ahead and see. Ran that apply. You can see it's going to add two things. It's going to destroy one. So that's something to always watch for when you're importing infrastructure is, you can easily destroy a database if you're not paying attention. So if we scroll up here, what's going to happen is we're going to start to see a lot of the attributes that are set on this Postgres database. And this is where I think you can really start to hone in on the DevX around how you're going to build this module, what you're going to expose to your developers, right? Right now, we're looking at just one database. What I'll usually do when I'm actually bringing in production infrastructure for a customer is everything we just did, I'll do it twice, literally two modules. And what I do while I'm doing this, or I'll use workspaces, you can go either way. And I will import maybe a staging database or a QA database, and then I'll import the production database. And then I will diff these two blocks that we see right here. So what we're seeing here is Terraform is telling us based on the state and our variables what it's going to change. And so what we see here is there's a lot of information that came through. And what I'm trying to do when I take those two versions of this and diff them is trying to get an idea of the interface I want to create. So we're going to see as some values are going to be the same. They're hard coded. Everybody is saying encryption true when they set up their stuff. Fantastic. Maybe they all have the correct tags, or maybe they're all using the same parameter group, right? I'm looking for things that I can actually just hard code. I want to minimize the variable interface that I'm creating here. I'm trying to minimize the surface area of the cloud with this module, right? And so I'm trying to look for things that are common. We're not going to do two different databases today because it just makes this take a lot longer. But I just want to kind of point that out as a really interesting way of like finding what is consistent across your infrastructure, so you know what you can hard code versus what you need to expose as a variable. So we can see this here. It's pretty hard for me to see because it's zoomed in so much, but you can see that there is a bunch of values that are going to cause it to force replace. So you can see this one, and that looks like it might be it. So it's effectively just the naming. And so what I immediately do is, knowing that, I will go ahead and I will change the name to this. And again, I'm just hard coding now. I'll back out variables when I feel like I found a good variable that my developers want to see. And I'm going to kind of stay in that tight loop. I'll tofu plan again. And what I should see now is that it doesn't plan to destroy anything, right? So I went through and I kind of focused on what was causing the state to change, and get that straight. Now, cloud resources are cloud resources. They're all a little different. So while Terraform right now is saying that it's not going to destroy this database, Terraform is actually lying. I'm going to stand up for a second. It's not going to destroy the database. Nothing about this configuration will cause the Terraform provider to delete the metadata for this database and then recreate it. But if you'll notice, I set this engine version, I just hard coded it to 14.7 because it was the last number I could think of that I knew was in RDS. But you can see that this database it's actually running in prod is 16.2. And so while this is not saying that it's going to recreate the database, it is important to notice that if I actually ran tofu apply right now, it would cause downtime as it started to downgrade that database and possibly lose a ton of data, especially if there was things that I was using that was 16.2 specific. So this is another thing that I'd probably almost immediately kind of back out and throw in right here. And then I'm going to look at the rest of these things here to see what I can kind of hard code in here. So you can see that there is some maintenance windows that are coming up that are trying to be changed to the defaults. And I might back all those out as well. I want to get as minimal changes as possible where I'm not seeing much change about this environment. So I'm going to go ahead and just kind of grab a bunch of these values. And again, I'm going to bring them in and hard code them here. Now, if I was bringing in real production stuff, I'd be looking at prod and staging side by side to kind of get an idea of what to set here. So I'm going to bring this over. I'm going to run down the side of this really quick and yank this off. And then I'm going to say major version no, copy tags to snapshot. I'm going to set that to true. We already have the engine version. Take ID off. I'm going to go ahead and hard code the values that were set on the server side, so that we're going to see as little changes as possible. And then try to just get as much of that. There we go. Now I should even see a much simpler plan here. There you go. It still wants to change something about this, but there's not much. What does it want to change? Allow resource or major version false. It's trying to change the serverless scaling config. Okay, cool. That's good to know. Okay, so before we kind of move more through this, what I'll point out is what we just kind of did here, where we backed out these values. If you would have used the Terraform import and generate command, you would have ended up with something very similar right here. And it's great to go that route if you're not using a module. Since we're using a module, it's a bit more cumbersome to do that import. But you would end up with something very similar. You'd end up with essentially just the code for the resource and all the values hard coded in there. So I am kind of okay with this, just looking at it for now. there is this scaling config that I may want to just go ahead and set too. It might be one of the last things that it's kind of catching on. So let's go ahead and set that one and then do a tofu. Okay, so this is one of the things that does suck a bit is I don't know what the name of this field is. I know what the name of the actual resource field is, but not what this modules field is. And so that's one thing you'll kind of have to play with a bit is like, do you have the variable names or do you have the attribute names correct here versus the real resource? So max capacity, so let's do max capacity. Let's go ahead and set max capacity. I'm just going to set it to 1.0 now to see what happens. Okay, so password is true. So it's adding a couple of things. Let's go ahead. So it's not setting that local write forwarding. Okay, I think this is good. Okay, so effectively I've got a module that's like ready to go. I've got some state locally, and I haven't backed out any variables for this yet, right? So now there's definitely a lot more attributes to set. We saw that there was 16 different resources that we could import. We'll start importing some of those here in just a minute, but right now we're at a place where I can deploy this. I might want to turn off this security group specifically because I don't know what this security group is going to do. So I'm going to go in here and see if I can figure out how to disable this through the module. I want to get just this one resource focused on for now. So I'm going to hop back over at the code and try to see if there is a create command for this so I can disable this one really quick just so we don't spin this up. So security group, where is it? AWS security group. Okay. Create security group. Sweet. And it does actually expose an attribute. Okay, so let's go ahead and set that to false. Now we should only have one to change, hopefully. There we go, one to change. So at this point in time, we've kind of very narrowly scoped this Postgres module down to just this one resource that I'm trying to import, my main resource. I want to get that under management. And then as I get that under management, I'll start to back out the user interface for it. Essentially the variable interface I want to expose to my developers. And also start to bring in some of those additional resources. Okie doke. So I am going to go ahead and throw this in now. I just noticed that one other thing that just showed up as something that was going to change. Okay. There we go. I feel pretty good about that. So it doesn't really look like anything major is going to change. It's going to set a couple of values, which I don't think are a big deal right now. So I could go ahead and Terraform apply this. My state's local right now. I want to get this into our state storage engine, so it's using it there. So let's go ahead and publish this bundle. So again, we're looking at a Terraform state file here, or sorry, not Terraform state, Terraform module. I'm going to switch back up to the root of my directory, ls, and this is essentially the top level directory here. This is where my Massdriver bundle is. So there's this Massdriver YAML file here that essentially is manifest data. It kind of describes what the bundle is, description, title, that kind of stuff we saw earlier, and also my artifacts, essentially my dependencies that I depend on. So I want to go ahead and publish this to Massdriver and essentially put it in the registry. So I'm going to take this bag of source code, I'm going to push it into the Massdriver registry. Normally, this would be a part of your CI/CD system and GitHub Actions. You commit your Terraform modules, and then once your modules are merged into main or you cut a release of a version or whatever, it would publish it into our registry. And so I'll show you how that works here as we start to kind of work through the rest of this state. Okie dokie. I missed something in my Massdriver YAML file. I actually know what it is. Infrastructure. And we'll kind of get into some of this other stuff here in a little bit. Mass bundle publish. Okay. Okay, so that is published. So I should now be able to see this in Massdriver. So I'm going to head over here, and I'm going to actually, I was playing around with it earlier. I'm going to take it off my canvas really quick so I can show you what we did. So we're going to start with just a VPC. So I already have a VPC that's deployed in my account and managed with Terraform. If I look at my sidebar here, you can see there's this Terraform module that we just published for AWS Aurora Postgres. I'm going to go ahead and drag this out. I'm just going to call this database. One of the things the platform does is it manages naming conventions, and we'll actually see this come down in a context object when we do our provisioning. It has things like URLs for alerting, naming conventions, tagging conventions, stuff like that. So it's just a big bag of metadata. And one of the things you'll get is this kind of resource naming convention. So add this to the canvas. You can see Massdriver's smart about those artifacts. So when I dropped this Postgres instance on earlier, we said that it's going to depend on a VPC. And so it was able to see that there was another Terraform module that outputs VPC information on my canvas. And so it automatically kind of does the rigging of the variables from that one, or the outputs from that one module into this one. So we'll have that there in a second. And when we click on this module, what we'll see is nothing really exciting over here on the side. But this is effectively your Terraform variables, OpenTofu variables, Helm chart, whatever you have in your infrastructure as code is going to influence the UI in Massdriver. And this changes per resource that you publish into Massdriver. So we can actually take this GUI dashboard now that your engineers are going to use to kind of draw your infrastructure. As they're drawing infrastructure out, it's using your Terraform modules. It's running your CI pipeline that you've kind of packed into that bundle. And then it gives them a customized interface to be able to manage that infrastructure. And so what I'll go ahead and do is just kind of illustrate how this works really quick by just kind of manually tweaking one of these fields over here and then pushing it up, and we'll see how that works. So just to kind of show the UI-ness of it. So let's go ahead and do this. So we want to add let's say we wanted to let people set the engine version of Postgres. So we're going to call this var.engine version, right? Maybe we'll come up here, we'll do a variable, engine version. There we go. I like to set the default to whatever the default was. Again, I'm going to come over here. I like to make sure I'm always getting clean. Okay, cool. So that looks like it is ready to go. And now what I'm going to do is I want to be able to take this engine version, right? And I want to be able to expose it to my developers in a couple of interesting ways. So maybe I want developers to always use the bleeding edge for development, but for prod, we've kind of standardized on 14.7. So Massdriver has this crawl, walk, run approach to it. You can essentially codify a lot of your policies, procedures, validations, etc., into this Massdriver YAML. This is a full configuration file that lets you really customize the platform. And one of the things you can do is not just limit the surface area of these fields, but you can also put in example values and example configurations. So you can kind of guide your developers on how to manage or configure that infrastructure. So I'm going to say that this engine version, and we have a tool called Airlock that you can use to kind of keep these things in sync. I'm just going to do it manually though, so we can kind of talk about it instead of just having something code gen a bunch of stuff. So I'm going to say engine version is required. Again, if you're using our Airlock tool, it would keep these two things in sync so you don't have to do this. I can give it a really nice name. Let's call it Postgres version, right? Thinking about what the developer needs here, right? In our code, we might want to call it engine version because it makes sense to us, the people that are doing this ops work, writing these modules, because that's what AWS calls it. But to a developer using it, they might just think of it as the Postgres SQL version, or maybe even just version, right? So you can kind of give it these nice titles, the version of Postgres SQL to use. You can set defaults here if you wanted to. Let's just set 15.0 just so you can kind of see how that works. And then you can also do things like enums. So I could say 16.2, 16.1, 16.0. I'm not sure that all these are versions that are supported by Aurora. I should double check that. But let's just go ahead and publish this for now to see how it changes the UI. Now I'm going to come back in here and refresh real quick. You can see that now I've got this cool version drop down, right? And so you can see, like, while in Terraform, I've got these very, variable looking names that aren't necessarily friendly. Here now I'm getting this version. It's named version instead of engine version. I can put a description, right? I can do things like list of current versions. I can do markdown here, right? I can republish this to the platform, and I can effectively be pushing documentation up into here. I also have this, as I mentioned earlier, I have this operator file. Right. Let's say I wanted to put a guide in here on like how to manage PostgreSQL. Right. And so what's really cool is now this bundle concept. I can take some Terraform, I can put it in my bundle. I can put my guide in my bundle. I can put my CI configuration in my bundle. I can put an additional configuration file that lets me fine tune this user interface. And now as an operations person, I'm seeing and working in the IaC tools that I know, but I'm really able to push a lot of functionality out to my developers so they can self-serve. So this is just kind of like a little taste of this. Just want to kind of show this a little bit. We'll hop back in and start doing some more importing here. I'm going to go ahead and check for questions. No questions. Okay, cool. Let's go ahead and close this. So I've got this one variable backed out. I have this one variable backed out. Massdriver YAML. So what I will kind of whiz through really quick is essentially our connections. So you can see that I require 2 of these right now. AWS credentials and VPCs. And so what's interesting is, like, I need the credentials and I need this VPC information at the Terraform level. What's really cool is in Massdriver, the way our remote state works, or our artifact system works, is you can pull this information from other modules, and everything is a schema behind it, essentially a contract behind it. And so these are the contracts for this. So we have definitions of what a VPC output should look like from Terraform. And what's nice about this is, if this is already on this module, it's not published, or sorry, that we published, but what you'll see is there's no fields on here about AWS credentials or VPC. And so when you add these connection types versus parameters will show up here. Connections are pulled off of other places in your canvas. So you can see this VPC connection here is pulling that information from this VPC. The credentials happens to be picking it up from this default credential that I have set for my entire canvas. So again, it's really cool. If you think about all of the attributes that a developer is going to have to set on a Terraform module, what this is doing is trying to limit that. So they're literally just getting the view of the world that we want them to see, right? I'm writing Terraform, I'm writing Helm, I'm focusing on OPA. My developers are essentially getting a very customized pass where they can get whatever they want, have a diagram, and then kind of this other tooling around it to make it easier for them to manage. So why do I say that? Well, I need to go ahead and modify my Terraform a little bit to kind of deal with these connections that are coming in. So the first thing I'm going to do is look at my providers, and you can see that there's a whole bunch of information here. So what I'm going to do is I have this AWS credentials. Actually, I'm just going to call it authentication. Let's rename it here really quick and call this network. And so what this is this really deep structure. These are actually pre-published types that exist in the Massdriver API. There are types that validate on each side. So if you build this VPC and you don't adhere to this type on the output, it'll actually fail. It'll deploy the VPC, but it'll return an error saying like, hey, you haven't properly rendered your outputs. It's same thing on the inputs over here. I'm expecting this same structure. So what's nice with this is, if you're using something like Terraform state or OpenTofu state and you're pulling between modules, you essentially have this implicit implicity dependency between two modules. A VPC outputs some VPC information, an RDS module uses it, I'm pulling it from remote state. As the VPC, the people that manage that VPC, I have no idea who's pulling that remote state. And also whoever's pulling that remote state can see the entire state file, right? Similarly, if I'm the RDS user and I'm pulling that VPC state in, if somebody changes that VPC's output, my state that I pull in also changes. So it could just introduce a breaking change to me. And so what our contract system does is it makes sure that both of these systems are essentially speaking the same format of what is coming out of these modules. So, so essentially I'm going to use that network information that's coming across the canvas and this credential information that's set on my canvas to set up my AWS provider. So I'm going to put my AWS database, my RDS database in the same region as the network. And I'm going to pull this authentication information from an IAM role that I've uploaded previously. What we're also going to do is we're going to see this default tags. Massdriver has tagging conventions built into it that it generates and pushes down into all of your modules. You can grab this metadata bag that we give and kind of use that to get a lot of conventions out of the box, naming conventions, tagging conventions, and they're optional. You can opt into them or not. So that'll write all that data in. That feels pretty good. And we're going to push the state up here in just a second. I just want to kind of work through this and make sure I haven't missed anything. And then it's AWS and then network. So the one other thing we're probably going to see here is I'm betting that there is some VPC information that I have to push into this module. So I'm going to hop over to the modules docs, look for that value, and then I'll route that artifact into it. So let's come back over here, look at my inputs. VPC ID, VPC security. So it just takes a VPC ID. Pretty straightforward. So what I'll go ahead and do, and again, like I'm not ready to like really put this in prod and start managing. I still got some hard-coded values in here. I'm just trying to take this step by step to get an idea of what a really good bundle looks like, a really good module with my state inside of it. And once I get it to a place that I feel really comfortable, then I'll let the platform kind of take over managing it and put the rest of my resources in here. So VPC ID, we're not going to hard code this. We actually are going to be able to get this information from our canvas. So var network, network.data, and then I believe it's infrastructure ARN. Infrastructure ARN, I believe, is the full path here. So these types, we actually define all these and publish these on GitHub. So I'm going to just pop over really quick and make sure I got this correct. Back definitions. And all of these, like you can clone this repo, modify them, republish them. Almost the entire Massdriver platform is customizable through the different open source templates and events, or sorry, templates and classes that we publish. So if I look in here, I want to see a definition for VPC. And yeah, it's infrastructure ARN. Okay. And you see that some of the other stuff that we put in this is we output CIDRs and private subnets and public subnets, internal subnets. That's all the stuff that we consider a really good output for a VPC. So we can kind of push that information down. So I'm going to get the ARN here, not the ID. And this is specifically looking for the ID. So I'm going to need to convert this from an ARN to an ID. I should remember how to do that, but I'll ask Copilot to do it to see if it can actually do it. Split this ARN and return just the ID portion. Okay, is that correct? Is the last part of the ARN? I can never remember. Let's go ahead and check for questions. Something over there. Okie doke. I believe that's about right. Let's go ahead and mass bundle publish. There we go. Okie dokie. I'm just looking at one more thing really quick. Okay, sorry, I'm just looking something up really quick. Just want to make sure that VPC ID is correct. I think it is. Well, we'll see in a second. We'll push it, and if it fails, fun. Okie doke. So I think we got everything we need there. So we got the network, we got the ARN. Okay, let's go ahead and push this. We have this updated. We call it AWS network. And then let's just do for, let's go ahead and mass bundle publish this. Oops. There we go. Okay, so now come over here and okay, cool. So now what we're ready to do is I'm ready to push my state up. So again, all my state's still locally. It's on my local disk. I'm going to push it into Massdriver's Terraform state server. And then what should be able to happen is I should be able to come in here and hit deploy, and it should hopefully deploy this database without destroying this database. So we're going to see. So if I got all those attributes right, we should be good. So I'm going to switch back now that's published up there. I'm going to switch back over here real quick. And I want to go ahead and publish my backend. So the way I'm going to do this, I'm going to hop back over to my providers file real quick. I'm going to go ahead and set that I'm going to use an HTTP backend. And so Massdriver makes a HTTP state server for Terraform and OpenTofu state for our customers that are earlier stage and they're not writing a lot of their Terraform. They're grabbing something from our template library. We've got about 90 modules there. Most of those people are using our Terraform state server today. It's a really great way to just get infrastructure as code up without having to worry about state. But you can also use your own state with Massdriver as well. So we want to make it easy to get onto Massdriver, but also easy to own and manipulate your state where you want it to be. So I'm going to just push this state into our HTTP server. And to do that, I'm going to go ahead and set a few environment variables. So the first thing I need is I need this Massdriver package ID. So this is essentially going to be your key. This is going to be your key staging. I want to call that staging database of where that's going to be stored. I'm just going to go ahead and set a couple of environment variables here real quick. Okie doke. So I set this package identifier and then the state address. Let's go ahead and make sure that's right. Nope. Looks like I copied and pasted it a little goofy. There we go. Let's try this. And then let's try that. Okay, echo. Do I not know how to use a computer? I don't. There we go. So that is where our state's going to be stored. I do need to set a couple other things. So I've already set up my Massdriver credentials in my environment. I'm just going to map those to Terraform's config, and then also set all the addresses for everything. So now what I effectively have is I've got all my attributes set up for managing my state remotely. If I look in the source directory here, you can see that I've got my Terraform here, and I want to push this from my local to remote. Form state push Terraform state. Whoops, nope, didn't mean to run Terraform, I meant to run Tofu. Sorry about that. Okay, Tofu init. Do you want to copy the existing state into the new backend? Yes. Great. Tofu plan. Let's go ahead and just set foo here. No, I'm going to set. So I don't have this variable set locally. Okay, that's good. We're good though. So I pushed that state up. So now what I should be able to do is I should be able to, my module's been published, my state is now pushed. I should be able to go into that module now in the UI, and I should be able to just set the single version field and take it under management in Massdriver. So let's go ahead and give that a swirl. Config here. I'm going to set this to 16.2 just so it matches that. Taking this database under management and hit deploy. Must be a string. What did I mess up over here? Oops, it's funny. Type safety. Oh, well, I will show you really quick before I select this is when we made those options earlier, where I said that you could kind of make those presets, you can see here development and production. You can effectively just expose these like real quick presets to your developers. So if they don't know how to run maybe Postgres in production, you can just give them a production preset. So I just set a version here, but you could do things like zonal replication, how you want to manage encryption, etc. So I'm just going to go ahead and select the 16.2, hit deploy. And we should see that the network property is not present. So let's go ahead and just redraw this really quick. There we go. Now it's starting to provision. So this should hopefully go good. I know that we're coming up on time here. I do want to check over for any other questions. But that's going to run in the background. So what we did today was, and we're going to do a part 2 of this here in a couple more weeks, where we're going to work from this point on and kind of build out the rest of these resources. What we did here is we took a database that was not, let me go ahead and bring me onto, take this off the canvas really quick. So what we did today was we took a database that was not in infrastructure as code. We took a Terraform module from the Terraform registry. We brought it into our own module using OpenTofu. We imported that state. We pushed it into the Massdriver state server, and then we made a bundle, a Massdriver bundle around it to kind of manage the UI, manage the state, manage the variables for your developers, and give them that nicer interface. And they were able to push that up in the Massdriver and have Massdriver take over the management of that. So I know that we didn't do a whole ton of Terraform per se, but the goal today was really kind of just to see how this flow works of getting existing infrastructure into the platform. So with that, I'll go ahead and check for comments one last time. Any questions? Doesn't look like we have any. And like I said, we are going to be doing a part 2 of this. So if you are interested in attending that, I'd say subscribe to our Twitter or our LinkedIn, where we'll be publishing the dates for the part 2 shortly. And if you're interested in getting started with Massdriver, just head over to massdriver.cloud. You can click the sign up button. There's a free plan, so you can go ahead and get started with a single seat. We've got about 80 different modules that are built into the platform by default for managing infrastructure. So if you don't have infrastructure today, or you don't have infrastructure as code today, it's a really great way to get up and running with RDS, EKS, secure VPCs, Dynamo tables, and we have resources for all 3 of the major clouds, Azure, GCP, and AWS. So if there's no questions, we'll go ahead and call it there. I'll hang on for a couple more minutes just to see if there's anything else coming through. But besides that, look forward to seeing you at the part 2 webinar. Okay, doesn't look like we have any questions. Awesome. Thanks so much for the time.